Hello friends, today we are going to study or solve question number 5 of exercise 1.1 real numbers. So the question says use Euclid's division lemma to show that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Friends, if you remember the same likewise question we did in the earlier video, that in the place of cube it was finding the square. Hence, I would recommend that you should pause the video and do it by yourself this question, and later you can cross check over it. Now moving on to the solution. As we know, the common ritual that we follow is to consider a to be any positive integer. Let a be any positive integer. And according to the question, if we look at the question closely, we can see that instead of b, they have given b equal. So we can consider b to be 9. But friends, as it is given that to show that the cube of any positive integer is of the form this. So for the simplicity, this would lead to a complex calculation when it comes to cubing. And so to have a brief or a small simple calculation, we will consider b as 3. Eventually we could consider this as 9 also by the question itself. This is also correct. I'm not saying that it is wrong, but for the simplicity of the solution, we will consider b as 3. Now, according to Euclid's division, the equation is a is equals to bq plus r, and we know that r is equal to or greater than 0 and less than b. Here we have taken b as 3, and hence the possible values of r can be either 0 or 1 or 2. So now substituting the values one by one and cubing both sides, we will try to find this given condition. When r equals to 0, we will substitute the value in this given equation. So a is equals to 3q plus 0. Now cubing both sides, a cube equals to 3q cube, which is nothing but a cube is equals to 27q cube, which we can also write as a cube equals to 9 3 q cube, and we will consider 3q cube as m to get this result. So a cube is equals to 9m. When r equals to 1, a equals to 3q plus 1. Now cubing both sides, a cube equals to 3q plus 1 to power cube. We know the formula of, let me write it over here. I'll write it over here. A plus b whole cube, which is a cube plus b cube plus 3a square b plus 3ab square. Okay, so now we will expand it in this form. Yeah, for expanding we will write a cube equals to 3 cube pi cube plus 1 cube plus 3 into 3 q square into 1 plus 3 into 3q into 1 square. Okay, now this can be expanded as 27q cube plus 1 cube. 1 cube is 1 itself plus 27q square plus 9q, which will give us 27q cube plus 27 q square plus 9q plus 1. We have written it in a more organized way. Now taking the common, 3q cube plus 3q square plus 1. Now taking this as m, so 9m plus 1 is what we are getting from here. Similarly, we will do for 3q plus 2 as well, and so we'll take the common and it will be 3q cube plus 3q square plus q plus 1, and we will consider this as m as well, and so we will get 9m plus 1. Again we will do it for when r is equals to 2. When r is equals to 2, so it will be a equals to 3q plus 2 per cube, squaring both sides. So we will get, again we know the formula, we have already mentioned it, so we'll quickly substitute the values and expand according to the formula. So it will result in 3q cube plus 2 cube plus 3 into 3q square into 2 plus 3 into 3q into 2 square, which will give us 27q cube plus 8 plus 54 q square plus 36 q. Now we will rearrange and write it and taking the common. So 9 we are taking common, cube plus 6q square plus 4q plus 8, and then again taking this as m, we get 9m plus 8, and hence we proved the lemma that cube of any positive integer is in the form of 9m, 9m plus 1 or 9m plus 8, and hence you got the answer. Friends, please subscribe to my channel and keep watching my videos. Thank you so much.